Welcome back to Unit 4, Lesson 6, Day 2. So today we're going to be looking at kites. That's going to be our main idea for today. So this is Theorem 2.5 and 2.6. So let's take a look at our first example, example 6. So if KLMN is a kite, find measure of angle N. So we know from Theorem 2.6 angle K does not equal angle M. And if we look here, K is 71, M is 52. So we know those two angles are not equal to each other. What Theorem 2.26 tells us is that these two angles are going to be equal to each other because we know that this is a kite, and it says if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So angle N is going to be congruent to angle L. Well, how's that going to help us? Well, that's going to help us because measure of angle K plus measure of angle L plus measure of angle M plus measure of angle N equals, how am I going to find all this? Oh yeah, I have a formula from Unit 4, Lesson 1 that says the number of sides minus 2 times 180 will give me the interior angles. Well, this has 4 sides, so 4 minus 2 times 180 is 360. So start plugging in what we know. So we know K is 71. We don't know what L is, so measure of angle L. We don't know what M is, so measure of angle, we do know what M is. M is 52. We don't know what N is, measure of angle N, equals, as we said, this is 4 minus 2, which is 2. 2 times 180 is 360. But we set up here that N is congruent to L. So that means N equals L by definition of congruence. So 71 plus, I'm going to change this L over to an N, measure of angle N, plus 52 plus measure of angle N equals 360. What good does that give me? Now instead of having two unknowns, I only have one unknown. So I can put these two together. This gives me 2 measure of angle N plus 71 and 52 gives me 123 equals 360. Now I got this equation. This is basically like an x. This is 2x plus 123 equals 360. So minus 123 from both sides. That gives me 2 measure of angle N equals 237. Divide by 2. The measure of angle N equals 237 divided by 2 is 118.5 degrees. So we found N as it asked us. Let's go ahead and let's take a look at the next example. So now we're going to look at example 7. So there's a lot to example 7, but it's okay. So we want to find the lengths in the kites. So we got quadrilateral ABCD is a kite. We want to find the perimeter of this. This would be B up here. I know it's kind of hard to see, but this is B. So what I want to do is I want to find the perimeter. Well, because the diagonals are perpendicular, we end up getting 4 right angles. So this becomes a right angle. This becomes a right angle. this becomes a right angle, and this becomes a right angle. Okay, great, Mr. Miller, those become right angles. How's that going to help us? Well, I have this, and I have this. I need to find this. Hey, this is a right angle. I have the two smaller sides of the right angle. I can find the third side of the right angle by Pythagorean's theorem. I can use Pythagorean's theorem to solve for that missing side. The missing sides for my figure are all the hypotenuses. So that will help us. We will be able to use Pythagorean's theorem that we've used so much before to solve this out. So let's go ahead and let's put it in. So what we're going to do is we're going to start off with finding AD. So we're going to find this one right here. So we're going to use our first leg and our second leg to help us find AD. So AE squared, so that's one of our legs, plus ED, that's our other leg, is going to give us AD, which is our hypotenuse. So we have 12 squared. Again, I'm getting that from over here, plus 24 squared equals AD squared. Well, 12 squared is 144. 24 squared is 576 equals AD squared. Add these two together, that gives us 720 equals AD squared. Take the square root of both sides, so I get the square root of 720. And the square root of AD squared is just AD. This isn't a perfect square, so I'm going to have to type this into my calculator, and I get out about 26.8. All right, so we've found AD. Well, do we have to find CD over here? No, we don't have to find CD because we know that AD is congruent to CD. So we know AD is congruent to CD, and we know from congruency that they are going to be equal to each other. So we know CD is going to equal 26.8. Well, what about these ones? We got to find these ones next. So now we're going to find AB. So we're going to do our two sides right here. So one of our legs is 12. Our other leg is 6, are our A values and our B values. So AE squared plus EB squared equals AB squared. So A squared plus B squared equals C squared. That gives me 12 squared plus 6 squared equals AB squared. 12 squared is 144. 6 squared is 36 equals AB squared. Add these two together, I get 180 equals AB squared. Take the square root, I get the square root of 180 equals the square root of AB squared is just AB, and this is about 13.4. Just like we did over here, I see that AB and CB are congruent. AB is congruent to CB. What does that mean? That means that this is 13.4. This is also 13.4. So now I can find the perimeter of this figure. So perimeter equals AD plus CD plus AB plus CB. But as we said, this is this, this is this, so we get 2AD plus 2AB. Because these are the same, so I can add them together. That gives me 2 times 26.8 plus 2 times 13.4. 2 times 26.8 plus 2 times 13.4 gives you a total of 80.4. So the perimeter of this kite is 80.4. So again, I started off with finding out by the definition of kites that these are diagonal, so they're going to create right angles. And then from there, I was able to figure out my lengths. So review through your theorems for today, theorem 2.25 and 2.26, and then use these problems to help you out with the practice.